This is Chapter 7, Problem 38. We are accelerating a mass of 1.5 kilograms by a non-constant force, a variable force, and that force is given by 2.5 minus x squared, and that force is directed along the x direction. That's where the I hat is coming from. In order to find the work done, we're going to integrate the force. So we're going to take work is equal to the integral of f dx, and that's going to be equal to the integral. The lower limit, we're going from 0, we're going to 2 meters, and we're integrating 2.5 minus x squared dx. So now we're going to get that the work done is equal to 2.5x minus x cubed over 3. That's the integration, and we're evaluating that from 0 to 2. Notice that my handwriting is getting excessively sloppy here. And so, when you plug that in, you should get an answer of 2.33 joules. 2.33 joules. Notice that the lower limit of 0 is going to go into both quantities, so the only thing that we have to worry about is the 2. They get a little tricky with the second part of problem 38 by asking you for the maximum kinetic energy between x is equal to 0 and x is equal to 2. That word max needs to jump straight out at you and remind you that you need to do some calculus here. Whenever we wanted to find the maximum of some function, we took the derivative and set that equal to 0. In this case, to find the maximum kinetic energy, we're going to take the derivative of the kinetic energy with respect to x. Remember, though, that the change in kinetic energy is equal to the work done. So we are actually taking the derivative of the work with respect to x. And when we integrate the force, we get the work, so that means that when we take the derivative of the work, we should get the force. So to go through that again, we're taking the derivative of the kinetic energy to find the maximum kinetic energy. The change in kinetic energy is equal to the work, and that means that when we take the derivative of the work, we get the force because the integral of the force is equal to the work. So that means that we're going to set the force equal to 0. Setting the force equal to 0 means that we're going to have 2.5 minus x squared equal to 0, and we solve for x, and we get an x value equal to 1.58 meters. And now we can plug that x value back in for our kinetic energy, and so now we have that the kinetic energy is equal to 2.5 times 1.58. Notice that I'm using the same equation that we found before in the last part after we had integrated the force, and then we subtract 1.58 cubed over 3, and we get a maximum kinetic energy equal to 2.64 joules, and that 2.64 joules happens when x is equal to 1.58 meters.